This tutorial was originally made for BlenderGrid.
Okay, forgive me if you've seen this one before. This is, so we've got an object info node and random going out of it into a colour ramp, and that's the colour for the glass material, which is what we're using for each of these coloured marbles here. Now, the way it works is it will come up with a different random number between 0 and 1 for every object. This random number between 0 and 1 will go into this colour ramp, and it will pick a random colour somewhere here. Okay. But what I want it to be more colourful. I want more colours and more randomness. So I'm going to add a combine RGB. Let's drop that in there. I'm going to put random in there, duplicate that, and then I'm going to put random into the green and the blue channels as well. So now we've got an entirely random. Oh, yeah. The thing is, you only get one random number per object, not even per material, per object, let alone per object info node. There is a way around this, and it involves my favourite node, the math node. So I'm going to add a multiply node, value 5. This is going to be a modulo. Now, I'm fairly sure you all know what multiply is, but what is modulo? Modulo is the remainder when the top value is divided by the bottom value. Okay, that's a bit of a difficult concept to wrap your head around when most of the action in Blender happens at the right hand side of the decimal point. Okay, so if I do modulo value to 1, that basically means it will only give you those digits that appear on the right hand side of the decimal point, and to the left hand side of it is 0. So if we put the random in here and output to there, what that's doing is it's multiplying it by 5, then it's discarding everything to the left of the decimal place, and then, well, that gives us basically a whole new random number. And to tidy this up, I'm going to select those two, Control G to group. Let me just, I want those the other way round, please. Select them, ding, and that one's going to be called random because we input a random number, and that one's going to be called prime. We're going to put prime numbers into this one and a different prime number each time, and we'll put the output, we'll call that random as well because it is a random number. Yippee! So if we tab out and then we call this more random, we can delete that now. That's just so we had a different input, and set that to 5. We now have a more random note there, and then if we select and do this here, only this time we select a different prime number, we get 2 more random numbers, and we could carry on if we needed 3 additional random numbers. The next prime number is 11, then 13, 17, and I don't know them all off by heart, I apologise. But now if we render, we'll get this. But we don't have to just randomise colour, we could randomise texture coordinates instead, which is what I've done here, so we don't get exactly the same piece of wood grain on every brick. We're basically using a tileable texture, which is colour, roughness and normal. But rather than going straight from UV into all of these, which would end up with, yeah, there we go, exactly the same piece of wood grain on every brick. A little bit obvious, methinks. We're instead going through this mapping load. I'm not altering rotation or scale, but what I am altering is location. Now, so I've got a combine X, Y, Z, so I'm basically able to control the X, Y, Z going into the location here. I mean, that's what I get there if I unplug this. And there you go. Everything's exactly the same again. Let's plug that back in. So, random here going into X. Fine. Random into Y. Well, I'm using that more random node I created in the last time. This time I'm using the prime number 13. But what if you want a little more control? Well, this one's pretty self-explanatory, really. This is the material for each of these glass marbles, and I've got the object colour as colour. The only question remains is, where do we set that? Object settings, viewport display, colour. That's where we set that. I believe that answers all your questions. But as you know, an RGB colour in Blender is basically 3 numbers between 0 and infinity. Yeah, because, you know, we could set this to like 40. The object now reflects more red light than actually hits it, but it works. Okay, so that's a bit more complicated. Let's go through it piece by piece first of all. So, mix shader mixing between transparent and an add shader. And that add shader is mixing between a glass and emission. Both of these two have got this colour ramp going into them. And emission is keyframed between frame 100 and frame 130. You see, it goes up. Let's zoom in. It goes between 0 and 2. Okay, nice. That's how I would normally animate a texture. But it does have disadvantages, which we will go into towards the end of this section. Another way to animate a texture is this here. This here that comes out of the object info color. This can be keyframed as well. And this, of course, means that you can have any number of objects with the same texture and have different times on the animation. And don't have to use it as red, green, blue. So here I've got a separate RGB. Red is controlling this mix shader, which fades between transparent and whatever else is on this material. And green is going into a colour ramp. So green is actually controlling which colour out of these 5 it is on its own. So if we look at this one here, we've got the white ball selected. Green is 0, which means that this colour is white. Here we go, it's this one at the bottom. Here. So here you see it's keyframed here. And it fades between red being 0 and on 60, red is 1. So it goes, except this, if you notice, it's not actually updating in the cycles preview. To make it update, we have to briefly jump back into Eevee. And also, well, I've actually set it already, but yeah, let's go with alpha hashed on both of them. You know about these settings for Eevee materials? Basically, we have to set them to be something with transparency, otherwise we won't get a preview. For some reason, this preview doesn't actually work in cycles. I'll do a bug report in a bit, I think. It does work in Eevee, and you can see that we're able to keyframe red on these. You see that I've basically staggered the keyframes so that the point at which red starts to fade in and finishes fading in is staggered. The other advantage is, okay, so if I've got a complicated scene with about 40 odd objects in it, it is handy to use this button here so that we can only see the keyframes for the selected object. And you've noticed something missing here. We get the keyframes for this red value of the object colour turning up. But what we don't get is the keyframes for this emission node. There should be a keyframe for there and there as it turns up. As you know, it's keyframe between 100 and 130. I told you that earlier. If we select it, we do. But like, I might not even have this open. And I would still kind of like to use the reference of when the material is keyframed. However, if you do it all with this here, we'll be able to see all the keyframes here. We can open this up and see the RGB and alpha. That's the point. I could have used alpha here, except that I don't have a separate RGB alpha node. I only have separate RGB. So I can't, though there is an alpha value on this colour here. There you go, there's an alpha value there. I can't actually get at it, which is why I have to use this trickery with using red for that and green to control the colour using a colour ramp. I mean, ideally, why don't I use blue to control that fade to the turning up of the emission shader at the end? You know what, I could, except I just wanted to demonstrate how this cannot be seen. Anyway, I hope that shows you why animating a texture using this colour has a load of advantages. Okay, this is what was on the thumbnail. This is what you've come to see. I'm using Lego bricks created with an open source program called LeoCAD, and I'm using pixel art created for the Commodore 64 game Creatures. Actually, I think it's Creatures 2, created by Steve Rowlands, coding by John Rowlands. Music's also from Creatures 1, actually. So, what's going on here? Well, for a start, I'm going to pause that animating, and I'm going to go to this view. And we'll see that we basically have got a whole stack of 21 by 12 Lego bricks, which is the shape of a multicolour C64 sprite. Multicolour means you get all of 3 colours plus transparency, by the way. Plus there's this additional one that's sort of above the top corner here. Right, I'm going to zoom into this area with Control Space. And I'm going to get that menu out of here, and we can see the world origin 000 is actually, well, you can see from these 2 lines, it's actually in the bottom left hand corner of the bottom Lego brick. But the bottom Lego brick is actually, its origin is actually a little way above and a little way to the right of the world origin. Now, the reason why we put this brick up here, which we're never actually going to see, and we should probably delete it, is we want to get the location, the X and Z location. If we were working top down, we would be getting X and Y location, but we're actually doing this side on. Now, you might think, can we not just project a pixelated image on the side of this? And the answer is no, because what would happen is each of these bumps would then be the colour of the next brick above it. Whereas they shouldn't be. They should be the colour of the brick below. I mean, if it's 2 coloured bricks, you probably won't notice, but if we jump back to here, if it was a transparent brick, then these bumps would be transparent, and that would kind of miss the point and make it not look like Lego. One other thing to point out before we actually jump into the nodes is this is not an array. This is a collection of objects. The reason for that is, well, we're using object info. You may have noticed all the outputs of object info. This time we're actually using location. And if we have an array, it's basically all one object with a single location. It's not a collection of multiple objects, which is what we want here. So we've just essentially duplicated an object loads of times. Alt duplicated, so they're all exact clones. If I edit one, I'll edit all of them, but multiple objects nonetheless. If you want to use dupliverts or duplifaces, I'm not going into them in this tutorial, but yes, you can use them. Okay, now, just as I've minimized it, let's actually have a look at that collection of nodes. So, well, essentially we've got a Pung image here, or Pung sequence, which is the pixel art. 72 frames, it's set to cyclic and auto refresh. Very important, this is set to closest. If we set it to linear, it's cross-fading between one pixel and the next. It's not actually cross-fading the alpha because, well, if we look at these and our Eevee settings, we'll see that they're both set to alpha clip, so we don't get levels of alpha, we just get on and off. I mean, if we set it to alpha blend, that just not liking that at all. So let's go back to closest there. And in fact, let's go back to alpha clip there. That just looks so much better. It works fine in cycles, which is what I used on the animation of the introduction of this section, but not in Eevee. So, what's going off with these nodes? We've basically got a principled, which is the colour of each one. The base colour is controlled by this texture, as is the alpha. But the input, well, if our pixel art collection of objects was, if we were looking face down at it to get our pixel art, which is completely legitimate, and if the size of this collection of objects was such that the bottom left hand corner was at 0.00 and the top right hand corner was at point x equals 1, y equals 1, The position of Z doesn't matter if we're doing top-down pixel art because it's just top-down, it's just a 2D image. But yeah, if X and Y were both 1, then we wouldn't need this mapping at all. We would just be able to go off object info location into vector, into whatever shader we choose to use, into output. However, well, for a start, we're doing it vertically rather than horizontally. And what that means is we have to rotate it along X by minus 90 degrees, the texture. We've done that. But we're also scaling it. What would happen if I pulled this scale off? We would basically, well, I've actually already set that to that, but say I've not adjusted anything, it would assume that the top right-hand corner of this would be at position X equals 1, Y we don't really care about, Z equals 1. And while the position of this piece, if we jump over here and see the location, while the position of this piece X equals 1, Z is considerably less than 1. It's 0.692. So what I'm going to do here is, rather than set these individually, which I guess I could do, I could actually work this out and do it individually, but I've chosen to do it like this so I can see my working. I've got a combine X, Y, Z here, going into that, and I combine X equals 1, Y, as I've said, makes no difference at all because it's 2D, and Z, well, Z we've got 1 divided by 0.692, which is this value here, 0.692. If X was not at position 1, then we basically have another of these. In fact, I may as well show what we should have by the same method. 1 divided by 1.